Okay, so we were on this stage where we wanted to say find the shortest path between all pair, and we said say these are the initialized matrices weight and parent matrix. Okay, now if we want to put node 1 as an intermediate node, so that means the value of reaching from any node, say node 5 to 1, will be calculated based on 5 to 1 plus 1 to 1. Now 1 to 1 is 0, so these values will never change in this iteration. Okay, so I can put this like this. Okay, so these are the highlighted value. Now there is a numerical trick also that every value here in this matrix you have to compare with. So if I particularly highlight a value here, maybe this in okay, which value I can take? Okay, maybe this infinite I can take. So if any value I want to compare is with the respective addition of these green tabs, so on the vertical, on the horizontal. So this is 2 plus 5 7, you need to compare with this infinite. And this is the same as the algorithm says, because the cost of reaching from 5 to 3, instead of reaching 5 to 3 directly, now we are saying 1 is an intermediate node. So what we are doing is that we are saying either we reach from node 5 to 3 directly as stated in the previous step, or instead we will move from node 5 to 1. Okay, and from node 1 we can go to node 3. Okay, so plus node 1 to 3. Okay, some of you who have say already booked some tickets to some uh, foreign countries, you might have seen that sometimes say a direct flight to that country will cost you much, but if you go via say some layover on some other city, so you or other country, maybe say if you are traveling from here to India to maybe US, and you are taking your stop in Frankfurt or somewhere in Germany, so you are moving from 5 to 1 and then 1 to 3. Okay, so this is how it's done. So let's check for each and every value. Okay, so this is just for the explanation purpose here, removing these comments so that we can clean. Okay, now so this 0, okay, cannot be updated to any other value because there is no negative weights in here. Now the 3, so the 3 will be compared with two values, that is 5 plus 5, that is 10. The earlier value was 3, which is a small, so there should be no change. Similarly, next we go is infinite plus 5. Now infinite plus any number will give you infinite, so this will not change. And then 5 plus 7 is 12, the value is 9, so no change. Similarly, 9 plus infinite will have no change. 9 plus 5, this value is 0. 9 plus infinite. So if you have an infinite in the column, in the color, that means the row which you have selected, then there will be no change in that particular row. Similarly, if infinite in one of the column, sorry, here it was in column, so if it is in the row, then there will be no change in the row, so you don't need to check these values. Now here 9 plus 7 is 16, so this value is infinite earlier. Now the new value is 16, so this value can change to 16, or 16 is a smaller number. Now 2 plus infinite, there will no change. 2 plus 5, the value will be 7, so this infinite will change to new value 7. Okay, okay, so there is no further change in the first iteration. And now since here we have changed and 1 was the intermediate matrix, then the value at this location, which is 3 comma 5, will be replaced with the value of 1 comma 5, because 1 was the intermediate node. Okay, so this value will take place at this location. Similarly, we have another change at say 5 comma 3, so that will be replaced by the value at 1 comma 3. So this value will nil will change with 1. Okay, so let's construct the new matrices. Okay, so that is M1 as well as PI1. Okay, so I'm selecting this matrix. Okay, so this is my M1. If I change this infinite into 16 and this infinite with 7. So never do correction on the same array, because it always takes the previous value and you might say do miscalculations. So it is always good to do it in the next array as the algorithm suggests. So I'm updating the values. Okay, so you are done with the PI1 and the W1, or what we named it as M1. Okay, so I can write this is your M1 matrix. Okay, here this is your PI1 matrix here. Okay, okay, now construct the second matrix. For the second matrix, the second node will be the intermediate node. No, don't worry about these number of the nodes or the node number. I can represent it as second, I can represent as a bth node as the intermediate node. Okay, so now highlight the bth node. So this is the second row, the column of the second node. This is the row of the second node. So these values will not change. Okay, I have already explained you the reason for this. Now let's see. 5 plus infinite is again infinite. The 0 will not change. Now the first value is infinite in this row, green color, so there will be no change in the first row. So I can put it all checked. Similarly, the value here is infinite, so there will be no change in this row also. So I can put it like this. Okay, now I can check. So 9 plus 5 is 14. So this value will change to 14. Okay, so this is the value 9. This value is 5. So I have taken 9 plus 5. This has given me 14. Okay, similarly 9 plus 3 is 12. The value is 8. So this value is smaller. So if I compare 8 comma 12, the 8 is the minimum value. So there will be no change here. Okay, this column is infinite, so no change here. Now 9 plus 9 is 18. So this value will change to 18. So infinite and 18, if I compare, 18 is the small number. Okay, infinite can be, say, some large number you can define. Now 6 plus 5 is 11. The value is 2, which is a small. 6 plus 3 is 9. The value is 7, which is a small. 6 plus 9 is 15. The value is 0. So there are only two change. Okay, the change comes when the second node is the intermediate node. So these value will cover in this way. Okay, so now we can generate the M2 and PI2 matrix. Okay, so this is Mi2, this is PI2. Okay, so once we construct these two matrices, okay, we need to do the changes here. So this value is 2. This value here is also 2. And here this value is now updated as 14. This value has changed to 18. Okay, now let's move to M3 and MPI3 now. So the third node is the intermediate node. Okay, so I'm highlighting the third node here, highlighting the third node here also. Okay, so these values will not change. Now let's come to the rest of the value. So this is 1. Oh, I have copied the wrong table. So this is a round table. I need to copy this table here. Okay. Yes, so this is correct. Now let me see if I have corrected this table. So this value is 2, this value is 2, and this infinite is now 14. This infinite is 18. Now the node 3 is the intermediate node, so I can highlight the node 3 here. Okay. So there will be no change in these particular values. I can calculate the rest of the values by utilizing these two. So 5 plus 9 is 14, 5 plus infinite, because this value is infinite, there will be no change in these values. I can directly mark them as checked. Okay, and these columns, because the value at this column is infinite, which is I can highlight here. That is the reason that this whole column will not get updated. Okay, similarly, the value here is infinite, so this whole column will not get updated. Okay, now let's fill the rest of the values. 16 plus 5 is 21, the value is 7, so will not change. 5 plus 3 plus 9 is 12, the value is 5. 3 plus 16 is 19, the value is 9, so no change. 8 plus 9 is 17, the value is 14, no change. 8 plus 16 is 24, the value is 18, will not change. 7 plus 9 is a large number. 7 plus 16 is again a large number, so there is no change in this matrix. So this is same as the next step. Okay, so I can just remove these headings. Okay, so maybe I should copy again, so it will be the same. Okay, there was no advantage of taking node 3 as an intermediate node so far. So this is C, E, will be just 2 more steps. Stay with me, and then we'll see how to trace paths also. So now the fourth node is the intermediate node. So I'm highlighting the fourth node. Okay. And the fourth node here. So there will be no change in these values. Now, if we see here, there are 3 infinites here. So that means there will be no change in these 3 rows. Okay, so these values will remain same. Now we just need to compare the last row. 9 plus 14 is a bigger number. 9 plus 9 is 18. 9 plus 8 is 17. So there is no change in this step also. Okay, so we'll directly move to the last step. So okay, so now fifth node is the intermediate node. Okay, I'm just coming back. Yes, so here we have seen that this is the nil value. Okay, now the next step, the last fifth step, is where I can put this fifth row and fifth column, which will not change its value. Okay, so now compare the values. So 7 plus 2 is 9, 7 plus 6 is my new value, which is equals to 13. Okay. Similarly, 7 plus 7 is 14. There is no change. 7 plus 9 is 16. So this value will change to 16. Now, 9 plus 2 is 11. 9 plus 6 is 15. 9 plus 7 is 16. 9 plus 9 is 18. So this value will change to 18. Okay. Similarly, 16 plus 6, this value will change to 22. Okay. On parallel, you can change the values on the parent matrix, but I'm doing it in the end. So this 16 plus 9 is 25. Okay, and there will be no change in the last row. So I have changed two values here, 13 and 22, which will take values from the last row, as this is the intermediate food. This value will be here, this value will go here, not there in the sky, but here. Yeah. And similarly, the last cell, so this value will get copied at these three locations. Okay, so that is this location, as well as at this location. Okay, so let's just create the last matrix. Okay, want them to be parallel to each other. Okay, and now make the changes. So this value is now has changed to 13. This value has changed to 22. This value has changed to 16. This has changed to 18 and 25 respectively. Okay. Similarly, if I see here, these values will change to value 5. This will change to 5. These values will change to value 5, 5, 5. Okay. Now there will be just the last part, this which is the tracing the final path. So if we want to find the, say, the path of reaching from one to another, so in the matrix in the left hand side gives you the value of the shortest path. So if I want to say what is the shortest path between node 1 to 2, you say the shortest path cost is 13. Okay, similarly, what is the cost of shortest path between node 4 to node 5? The cost is 18. Okay, now if I say what path will you take from node 4 to 5 to get this cost 18, or what path you take from node 1 to node 2 to get this cost 13? So to identify the path, we have to do the path tracing. Okay, let's go to the path tracing matrix, the path tracing function here. So let's define it in the form, say, path tracing. Okay, so in path tracing, we need to provide the input, which is the PI K I comma J, PIK, and the two values for which we need to calculate the path is, say, from node to node J, I to node J. So what will be the path between node I to node J? Okay, to identify that, we can check first condition if I is equals to J. If I is equals to J, that means you are on the same node. So if I is equals to J, if this condition is true, then the path you can simply print is I. So if you want to say move from node 1 to node 1, that means you can simply say print J. Okay, so we can print J. That means that's the only path. If you are on the same node, you don't need to say go here and there. Else, if I say my Pijk, okay, my matrix at the kth index provides me a value equals to nil. So if this is providing me a value equals to nil, then I can print that there is no path. Okay, so I can say print here that there is no path between I and no path from node I to node J. Okay, so then I can print this statement. If the third condition is true, okay, that is, else there is some value like 2 3 4 5, then if the third condition exists, then the path will be, say, we are gonna print J here, that the path will follow through J, and then we need to move from path tracing, okay, and from node I, now our aim is to reach at that value. Okay, if there is some value, pkij is giving you some value 2 3 4 or 5 or something like that, then that value. Okay, so let's see it with just one example here, that if I say find the value of path between node 4 to node 2, so we are finding the distance between a path between node 4 comma 2. So if I want to see that value here, so we see that 4 to, or maybe 4 to 1. Okay, so if we see the value between 4 to 1, here the value is 2. Okay, so we will first print 1 as the output. Okay, and then we will call a function from 4 to 2. Now 4 to 2 is again by the value 4. Okay, so the value 4 to 2, I is not equal to j, we will go into this and we will print 4. Okay, so 4 to 2, so we will print 2 here. Okay, now the value is 4 now, so we'll call another function from 4 to 4, so it will print 4. So the path from 4 to 1 is 4 to 2 to 1, so it will print the path in the reverse order. Okay, and we can see tally that values also. So the value of 4 to 1 is 14. Okay, and in our primary matrix it is given as 4 to 2 to 1. So let's see the primary matrix here. So if we see the primary matrix, the value of 4 to 2 is 9, and then from 2 to 1 is the value 5, and this 9 plus 5 has given a value of 14 to reach from node 4 to 1. Okay, so that is the end of the topic. Good luck. Okay, can end the session here.